Hi, and thank you for joining me today for another lesson of Unity from scratch. This is part 3 of the Parallax Effect series, where we explore the different ways to achieve a parallax effect in a 2D game. Today, we'll see how to create a parallax effect by moving the background along with the movement of the main character. So without further ado, let's begin. So as you can see, we're once again with the same assets that we had in part 1. I'll add a link in the show notes if you want to download or see where they downloaded from. We have our 5 sprites that consists of our background, which is the star, clouds, mountain, trees, and earth. And we have our wizard, which has only 2 options, standing and running, and we'll create a simple running animation from that. We have our sample scene, we have no animation and no scripts, so we can begin. First thing, we'll add the different parts of the background. Let's create a new game object. Call it background, and add, as you know, the different parts of the background one by one. Again, we do it one by one because if you drag them all at once, Unity will think that we want to create an animation. They're ordered fine. We don't need to do anything special here. They are also centered. Let's center them. Next, we'll just order them in the layers, so the stars are at the far back. We'll put them at -10, and then we'll go from there, let's say -8 and -6. And the trees and the earth are at 0, so they're on the same plane. Let's put them in -1, so maybe the wizard will be on 0. Now let's add the wizard. Again, it's way too small, so let's enlarge it. Yeah, and move it. Now let's add a rigid body. Note that you're taking the rigid body 2D and not the rigid body. And a box collider 2D. We'll just fit it. Okay. And we'll create a rigid body for the earth, a rigid body, a box collider. Okay, for the wizard, we'll also lock the rotation on the z-axis, so our wizard won't fall. And let's see what happens when we hit play. Yeah, it's standing in its place, which is exactly what we want. Great. For our character controller, we'll again use Brachy's 2D character controller. Brachy's 2D controller. And yeah, there it is. Let's copy it. Actually, let's copy the name of the class and go to scripts, create a new C# script and name it character controller 2D. Let's open it. Yeah, and now we can go and copy the rest of the class. just replace everything. Great. Again, if you remember, it's out of the scope of this tutorial, but we need to create some objects for this character controller to work. So let's just change this to wizard and create two empty game objects, which is ceiling check and ground check. And let's just add the character controller to the wizard and drag the ceiling check to its place and the ground check to its place. And let's just quickly put them in the right position. And last, we need to put the background in its own layer. So that's what we have here. We have nothing, so let's add a layer which is ground. Let's say it's ground. And we'll add just this sprite to the ground. So now the wizard, we need to tell it what is ground. Ground is ground. Great. Again, let's see that we haven't messed everything up. Still working. Now we just need to create a movement controller. Let's call it wizard controller. And we need here the rigid body. No, actually, sorry. We need serialized field. We need speed. And input get axis horizontal. We need to save it in let's say private horizontal move. Let's give it a default value of 0, and also private bool is jumping. That will be false. We'll use it maybe later. So during the update, we'll I put it here, sorry. We'll save the horizontal movement to a variable, and we'll multiply it by our speed. And then during the fixed update, we'll just move the character by calling our character controller, which we need to also declare. This one. Okay, and now we'll just get it. And we'll tell our wizard to move. To our horizontal direction. We'll multiply it by time, delta time. It's not crouching and is jumping. Maybe we'll handle it later. So if I did everything correctly, we should have moving wizard. But it's not, because I forgot to add the wizard script. Now it's still not working, so yeah, probably misspelled that. Horizontal. And we need to increase the speed, because on 0 it will not move. Let's test it. Great. And one last thing, let's create an animation by dragging these two sprites into the wizard and going into assets, animations, and calling it wizard running. Great. Let's see if it's working. Yep. And now we have our wizard running a little bit slow, maybe 30. Yeah. So now we have our wizard running and we are all set up to create our parallax effect. Now the first thing that we want to do is we want to increase the size of our background sprites. We want to make them at least as big as the camera and or each side that the character can move onto. So we'll do it by selecting our stars background, and we'll go into the sprite render and we'll tell it to draw it by tiled. At the draw mode, we'll change the draw mode to tiled, and then we'll just increase its size. We can do it by stretching it. And that's a little bit too big. And the other side too. So, yep, that looks okay. We'll do it also for the clouds. Again, change it to tile and stretch it. And for the mountains, oops, tiled first. For the trees, and last for the ground. Okay, so now if the camera moves here or here, it won't get out of bounds. So this is exactly what we want. Now what we're going to do is when the camera moves here, we'll just shift our background that is going to get out of bounds and move it one whole section to this side of the camera. We'll do it in exact manner so the camera will not notice that we have shifted the background. So how are we going to do that? We'll do it by creating a script. Let's call it background mover. And we'll open it. What we'll need here is we'll need to know what's the position of the camera, and we need to know what's the size of the texture that we're drawing. So let's create our camera. And we need to know our texture size. So again, oops. And one last thing, we'll need a variable that will hold the speed of the background. Each background will move in a different speed, so we'll just keep it in a vector 2 because we might want to move it on the y-axis too. So we'll call it Parallax multiplier. Okay, and I think we're ready. So first, let's get the camera transform. So the camera transform is pretty easy to get. It's the camera. We want the main camera and its transform. So that's easy. We also need to save its last position because we want to know how much it moved from one frame to another. So let's save it. And we'll just get the camera position. Yeah. Next, we want the sprite. We'll get it from the sprite renderer. Now we need to calculate the texture size. So the texture size will be the texture width divided by the pixels per unit of the texture. So what this means is that we want to calculate the width of our texture, and we'll do it by taking the number of pixels in the texture, which is the texture width, and dividing it by textures per unit. We can actually see it here if we go and select our sprite before it's imported into a game object, and we can see that the pixels per unit is 100. And we know that the sprite has 1920 pixels on its width. So pixels per unit means how many pixels should be drawn in one unit of Unity. And 100, it means that it will take about 19 units to draw the whole sprite. But we want to calculate the real width of it, so we divide 1920 by 100 and we'll get to 19.2. So now that we know what these parameters mean, let's go back to our script. We now have our texture size, and this is exactly what we needed. And during the update, we would have, in normal circumstances, update the movement, but we are actually not using the movement of the character, we're using the movement of the camera. So we'll use late update. Late update is an update that happens just after every part of the scene has finished to calculate its new position and was drawn on screen. So for the camera, we really wanted to do after the camera has finished moving. So first thing that we'll do is we'll calculate how much did the camera move. We'll do it by subtracting the camera transform position from its last known position. So now we have our delta, which is great. Now we want to move our background in accordance to the camera movement. So our background is the transform, and we want to move its position. And we'll just create a new vector 3. And the vector 3 will have the delta movement. We want to add we'll add the movement of the camera to its x value, and we multiply it by our parallax multiplier, because we don't want to move it the whole way, we want to move it part of the camera movement. For the y-axis, at the moment we don't want to do anything, so let's just do delta. Oh yeah, yeah, great. And so we moved our transform, and we want to keep our camera position to save it. Okay, so now we have, we don't need that one actually. Now we have a simple script that first calculates the texture size and then moves the background along with the camera. So let's test it. So the reason nothing happens is because the camera is not moving. To move the camera, we'll add Sing Machine like we did in the previous tutorial. We'll go to Window, Package Manager, and let's select Sing Machine. We'll install it. If you don't have it, import it first. Great. Now we have Sing Machine. Let's create a new virtual camera. And we're going to tell it to follow our wizard. Yeah, it's a little bit too low, so in the transposer we need to increase a little bit the Y. Yeah, let's see now. Yeah, it seemed to follow our character. So if we'll just move it a little bit here and have a look at what we can see here. We can see our character moving from one side to side and the camera is following it. Great. So now let's add our background mover to all of these scripts. And one thing that we need to do is give a different speed to each background. So we'll just give a multiplier of 0.8 to the furthermost background, because we want to move it almost with the camera. It should move very slow, so as the camera moves it will match the speed of the camera, but a little bit less. Also, now the clouds will be almost the same. We'll put it 0.7. The mountains, we'll put it at 0.65. But the trees and the ground we'll put at 0.3. Now let's test it. Yeah, and we can see that the background is moving. The jitteriness that you see here is gone if we'll just put it here. See, it's moving very smoothly, so it's fine. See, the stars are moving very slow and the trees are moving very fast. That's exactly what we need. Great. Okay, so what we have left to do is shift the background once the camera is almost out of bounds of each of the background. So each background will need to handle its own shifting, and we'll do it in the script as well. Let's go back to the script. And in our last update, we need to check if the camera is out of bounds. So if you remember correctly, we calculated the texture size here. So we'll check if the camera position, if we subtract the position of our transform from the camera's position, and if it's bigger than our texture size, it means that the camera has moved one whole unit of our textures to the left or to the right. So let's do if our camera transform position x value, and we'll subtract the our position. Now if this is bigger than or equal to our texture unit size, texture size x, then we need to move our transform. So let's do transform position. We'll create a new position this time, will not add. It will be the camera position. And we're just keep the y-axis because we haven't moved on this axis. So let's see if this is working for us. We'll take the game and we'll put it here aside, give it a little bit more space, and we'll go far away so we can see the camera moving along the background, and we'll hit play and we'll move. The first thing that will go out is going to be our trees. You see, the camera is going to reach the end of the trees, and as you can see, we generated them. Let's do it again. And as we reach the end of the sprite or the background, the script shifts it. Now, a problem that we have here is that it's working nicely if we go to the right, but it will probably not work if we go to the left, as you can see. Oh my God. So the reason it's not working is because we only checked if the camera position is bigger than the position of our transform. So what we need to do here is actually check if the camera position is bigger to the left or bigger to the right. We don't really care if it's a positive or negative number. So we'll just add math f absolute. And if the absolute value of this abstraction is bigger than the transform size, then it should be just fine. Let's check it. Okay. And now let's go to the left. And as we near the trees, we go near the trees. Oh, you can see them. So now let's have a look and see if it's good. We're going to the left, and if you notice, there's a small shift. You can see it in the ground. The ground doesn't shift well. That might be caused by the fact that we are not accurate enough. To be accurate enough, we'll have to use an offset. So what does this shift mean? This shift is caused by the fact that when we reposition our transform, we position it in the position of the camera. The camera might have already passed the start of our transform. So there's a small gap, and this gap causes our jitter when we shift our transform. So to calculate this shift or offset, we'll have to do a small mathematical division. And we'll actually take the same subtraction of this, but we'll do a modulo which will give us the remainder, and this should give us by how much we overshooted our texture. And we'll add this offset to the new position. So let's see if it helped. We'll go left. Yeah, it seems to be working fine. Oh, I'll just move that here. And as we near the end, we should, yeah, that was pretty smooth. Once again, let's go to the other side. And yeah, no jumps, great. As a bonus, we'll add the parallax effect to the y-axis. If you remember, in our script, we added here the parallax multiplier as a vector 2. This means that we are allowed to change the parallax value of the y-axis too. Why would we want to do that? We'll want to do that if we want to create an effect when our character jumps. So let's add a jumping effect to our ability to our character, and we'll go to our wizard and we'll go to our wizard controller, and now when we are hitting the jump button, and we'll do it here, if input get button down and we want jump. So if we are jumping, we want to say that is jumping is true, and we're passing here to our character controller 2D that the character is jumping, and then we'll make it false. I think that's it. Let's see. And our character is walking, and when I hit space, yeah, it's jumping. Great. We might get it to jump higher, but as you can see, the background doesn't change when it's jumping. So we want to add a cool effect. So this is pretty easy to do. Again, the furthermost background will hardly move, and the nearest background will move a lot. So we'll take the stars and we'll give them 0.8, and this will also give, let's do 75. Mountains will do 0.65, and those will give them a 0.3. Okay. And we need to actually do something with these values in our script. So if we'll go to our background mover, what we need to do is take the parallax multiplier and multiply our delta move, but on the Y value. And that's it. Let's see if it's working. And we'll jump, and as you can see, there's a parallax effect. The problem is that we can see a gap between the mountains and the ground. We can fix it pretty easily by lowering the mountains a little bit. And maybe lower these two also. Let's see if it's working. Yeah, it's working. We lowered these two a little bit too much. Yeah. And now we got a parallax effect on the y-axis too. This animation is very annoying. We'll not use it in our next clips. I hope you enjoyed this clip and learned how to create a parallax effect with an endless background. If you have any questions, just leave them in the comments below. I'll be happy to answer anything that wasn't clear in the tutorial. And until next time, keep on coding. Bye-bye.